Hi everyone, good afternoon or good morning. My name is Dustin. I'm a math tutor. I have a YouTube channel. It's called Dustin's Fun Math. If you have a chance, please visit my channel. And if you like my videos, please subscribe. If you have any comments or questions, please let me know. I'm here to help. So let's begin with another fun math today. It's about integration, specifically about double integration related to multivariable calculus. So the question is asking find the value of A, and the way this is set up basically is an equation which you're going to solve it for A. So typical double integration has this form, and then you have a stuff here, whatever the expression is here, that contains the numerator and denominator. This one, the integration, the inside integration, as you can see, is in the denominator of this one. Doesn't include the inside integration of the numerator and the denominator. So it's slightly different than with the typical double integration we learn in multivariable calculus. But the process is very similar with this one that you want to solve. All right, so the idea is to solve this is to find the inside integration first, and then get the result, and then divide 1 over the result, and take the integration of the result and equal it to 1, and solve it for A. And that's what we're going to do today. So let's write the inside integration. Has interval from ax to a, then it has 1 over y dy. This is a predefined integration, which you should all know is going to be ln of y, right? And it has an interval of ax to a. One clarification is that why I didn't choose normal log like log rather than natural log ln, because we have an outside interval a to the power of e, and I know the base of the natural log is e, so that's why I chose natural log instead of log, the regular log. All right. So yeah, so let's substitute y with ax and a. So I have ln of ax minus ln of a based on quotient property of logarithmic functions. We have ln of ax divided by a. So this a cancels with this a, and you end up with ln of x. You're done. You're done with the inside integration. Nothing else you need to do. So now we're going to rewrite our outside integration or final integration, which is going to be interval of a to the power of e up to e. I have 1 over x, and the inside integration we found was ln of x, right? And times dx. So for this one, we don't have a predefined answer to this. So we need to use some of the techniques we use in integration in, I believe, advanced calculus or calculus 2. And we had integration by parts, we had u substitution and partial fractions, and etc. So the one that I would choose is u substitution. So I'm going to choose my u as ln of x, and I take the derivative of u, which is going to be 1 over x times dx. So I'm going to rewrite my integration, which is going to be integration of a to the power of e all the way to e, and 1 over x times dx is du, and 1 over ln of x is 1 over u. Again, we end up with another predefined integration similar to the inside integration, which this is going to be equal to ln of u, and the interval is a to the power of e to e. One note that the a to the power of e and e bounds are for x values, and u is not the x value, so you need to substitute back the u for ln of x. So this becomes ln of x, then you have the interval of a to the power of e to e. So that's very important to take a note of that. So yeah, we're just going to substitute right now the a to the power of e for x and then e for x and solve it. So let's get rid of this inside integration that we solved earlier, so I have more space to finish up the integration. Sorry about my board is a little bit small, so that's why I have to erase this inside integration calculations. All right, we're almost there. All right, perfect. All right, so the result of this is going to put the arrow here, is going to be ln of a to the power of e minus ln of e. So I start with the right hand side because it looks easier than the left hand side. So ln of e, we know natural log by default has a base of e, so basically it means is 1. And then ln of 1, everyone knows is going to be 0. So this one goes to 0. So you end up with ln of a to the power of e equal this 1 here. Now we have a simpler setup for our equation. It makes it much easier to calculate it. So this one, my idea is to bring the e in the backside of ln, but you can do it only when you have only one ln, not two ln's here. So I need to get rid of one of the ln to bring the e on the backside of ln, and I'm going to convert this left hand side to the exponential form. So this becomes ln of a to the power of e equal e. And then now I can bring this e back to the ln. So it's going to be e times ln of a equal e. This e goes away. They cancel each other because you can divide it both by e. And then you end up with ln of a equal 1. And you're going to convert this to exponential form again. So this becomes a equal e. And that is our final answer. So I'm going to write it here so you all know. A is equal to E. So that's our answer. So I hope you enjoyed this video. If you have any questions or comments, please let me know. And if you have any particular type of math problems that you want me to solve it through YouTube videos, you're more than welcome to ask me. Have a wonderful day. It was a pleasure being with you guys, and take care. Thank you. Bye-bye.